So thank you very much this afternoon. We have quite an interesting topic here. Sorry, I should go back to the topic slide, about machine identity lifecycle. And we're going to give a demo of the HashiCorp Vault product supporting these kinds of use cases. But before we get in, I'd just like to introduce the team here. Narayana and I are the founders of Gola Cyber, which is a HashiCorp business partner that's focused on zero trust security and cryptography. And Lan Cheng and Joshua are with us as part of our technical team, and they've been working on the demo for you this afternoon. This demo and presentation is also supported by our colleague Nalini from HashiCorp and by our distributor Tech Data, who have been supporting this series of webinars about HashiCorp Vault. So this is a series of demos and presentations about Vault. The last one we did was illustrating short-lived digital certificates using the analogy of a company that was operating a fleet of logistics drones. And the next one in the series coming up in a few weeks' time is going to be looking at using HashiCorp Vault to meet security and compliance use cases. And then later in the year, we will do one on securing agentic AI. So that's the introductions. Over to you, Narayana.
Thanks, Stephen. So I think I'll start with an example, right? So traditionally, developers, we create an API key. I have been a developer for most of my career. We have to get the work done. We have our own sprints and cycles, and we have our own targets in terms of completing. So things change. A developer might create an API key, the project changes, the owner might have left the company, and the application evolves. Next. But what happens is, would you like to click, Stephen? The key will still remain, right? So it still is valid, it is privileged, it's trusted, but whoever owned it has left. So probably people don't know about it, but down the line, many years later, an attacker would find it and nobody remembers it exists. So they haven't protected or rotated or revoked it. So the infrastructure still exists and the attacker can use the key in a malicious fashion and access the ones that it can access using that key. Next slide. And then your largest workforce, what's your largest workforce? Is it employees? No, it's not. It's machine identities. You have your service accounts, you have your API keys, you have your automation tools, your certificates and tokens that are kind of your employees, but they're working in the background trying to help you reduce your workload. They are taking the big amount of work. Next. They access your critical systems every second. They're working 24/7. We have our 8-hour shifts, but they do work all the time. But the key question here is like, who owns them? Who can access them? And what are the privileges they have, and when do they expire, and how quickly can they be revoked? So if I find that a particular attacker is using a key, do I know how to revoke it? How quickly can I act and remediate? Next slide. So the challenges the attack surface is probably changed, right? So the attack surface has expanded to your non-human identities. So what we need is kind of a solution that can initially discover all your secrets, your API keys and everything, and then bring them into a lifecycle mode where you can rotate, revoke based on your requirement, and you can have dynamic secrets, dynamic privileges, and you want to automate and rotate your certificates and keys and everything. And at the same time, you want to have some encryption, you want to have some sort of an RBAC, like you want to have policies on who can access this, when, why, and when should this key be revoked. You want to manage the life cycle. Another key use case is encryption, right? So we may want to encrypt from time to time data, and you don't want it to be too complex. So you can use the vault as an encryption as a service provider, and you can do your encryption requirements as well. So that will ensure reduction in the data theft risk. Next slide. In terms of vault architecture, so for some reason it's not very clearly visible there, but you have different kinds of secrets, and you have your cloud provider. We may have their own secrets manager and vault, and the HashiCorp vault will stay in between the users and identities and the cloud providers. You have your databases, you have your certificates, you have your dynamic secrets, and you also have your identity providers on the left, which can be used. You can use one of those methods like a token, or based on your IDP, you can authenticate to the vault and then request the secret you are after. And each secret might be governed by a policy which will determine whether you have access or not. So you can create an ACL, which is the main portion of the demo. So in this particular demo, they are going to show, Josh and Shiloh would show how you can create dynamic secrets, how you can rotate them, and also what kinds of policies you can apply, so on and so forth. So with that, I'll hand it over to Josh and Shiloh. Thank you.
Sorry, I just realized I was on mute. Can you all see that?
Yep.
Perfect. All right. So Vault's big thing is about defense in depth and how that can be used to secure machine identities and any identities and the secrets that they might hold and have access to. So we've got a lot of different layers here that are involved in that process, and we're going to touch on all of those pretty much today throughout the course of these demos that we're going to be presenting. So from the authentication and identity levels, talking about policies and access control, dynamic credentials, and making sure secrets can be rotated quickly. Determining the lease or the length that those secrets are active for, being able to audit and respond to incidents, and being able to revoke secrets if it becomes an issue. So as part of this demo, we're going to have a look at another chat company, or ACC, and we're going to discuss kind of this company's requirements in Vault. They want to have all their secrets managed centrally. They want to be able to ensure their employees can store and use secrets and make sure that administrators don't have access to secrets as well. So all of this is really important because there's a lot of, particularly with policies at the moment, which we're going to be discussing quite in depth with this demo. It's really important that we're able to secure all of those things. It's one of the first things that we need to be thinking about because what do? We can get our servers up and running. We can start migrating secrets into Vault, but how do we make sure that there's a line of defense, making sure that everything's all secure the way it's supposed to be? So your first instinct is probably to get everything into Vault immediately and get end users working, but a lot of cyber incidents start with the human factor. So 90% of cyber attacks start with phishing. It's a real threat to your organization and its use of Vault. So if all your users are immediately using Vault and there's no walls or anything like that, then there could be a massive security incident with all your secrets in one place. So we want to make sure that no matter what databases, servers, cloud infrastructure, GitHub accounts, AI agents, or more in companies' environment, in this case ACCs, while they're developing their next chat platform, we want to make sure that their secrets, while developing and running the platform, are kept secure and out of risk. So the focus on policies is on access controls, so preventing malicious insiders from accessing what they're not supposed to. And additionally, there's a lot of emphasis on AI agents. They're becoming very common in workspaces at the moment, and there's a lot of uncertainty about some of the security implications that they might have, like prompt injection or poisoning attacks, or even just general reliability. It's new technology. We don't know quite what controls need to be in place to prevent unexpected or unpredictable behavior. So no matter what the cause of an incident is, these policies ensure that the scope of an incident becomes contained. So even if an attacker does get into Vault, no matter how that might be, there's clear limits, and we know those limits before we start. So even once an attack is in the Vault, we know what they can do, and we can make sure that we can respond appropriately. So creating policies is one of the most important things in Vault, and when we're making those policies, we've got a 3-step plan to be able to do it. Planning, testing, and deploying. So when we're planning, we're defining exactly what users with the policy need to access. We're testing it in a non-production staging environment to make sure that users have the capability to do what they need to do, and then we deploy to our real Vault instance. So we'll walk through these steps in real time in this demo environment, and we'll start to get a glimpse into the world of Vault policy development, and hopefully start to see some of the powerful capabilities of Vault, and we'll go into some of the finer details as well as we follow through this process. So we'll very quickly show this off. We're going to get logged into Vault. Right, so we'll get logged into Vault and we'll have a bit of a look around. So we'll sign in with a root token first up so we can perform the setup that we need to do. So as you can see on this home page, we've got a KV test secrets engine, key value secrets engine that we're using on this instance to validate accessibility to secrets that we might end up storing in Vault. You can also see there's a warning for logging in with a root token. So that gives a lot of power over a Vault instance. So we want to stop using this as soon as we can to prevent any inadvertent security holes, which we do with our policies. So we've also got a cubbyhole secrets engine for storing, for wrapping tokens and that sort of thing. We've also got 2 test users that we've created, which we'll show in a second, one for testing out user capabilities and one to showcase an actual administration policy. So the first steps that we need to do is making sure that we get rid of this root token that's in use that we're using at the moment. So we need to create an administration policy for our user. The policies in Vault apply to all users, including our administrators. So we need to create a policy for our Vault admin user so they can access what they need to. Everything in Vault is defined as a path, or it's some sort of data located at a path. So this uniform platform makes it easy to control exactly what all users can see and modify in a single way. So as far as our plan, our administrator needs to be able to manage policies so that we can use this new user to create and update any other policies that we might need to create. They need to be able to manage the mounts, which define our secrets engines, and potentially create new ones as required. They need to be able to manage authentication methods to allow for the creation of new users or to apply policies to users. And we also want our Vault administrator to be able to manage the audit logs, as we've discussed, for auditability, being able to make sure we can see what secrets are being used when. And also while we're testing, ACC wants to be able to make sure that the secrets in this test instance of Vault are being used correctly and just get an idea of generally how much is being used. Additionally, we've got a couple of paths in here that enable access to the web UI fully, which requires a couple of extra paths than usual. And we want our administrator to be able to look at the configuration of the secrets engine that we've got set up, the KV test engine that we saw earlier, but we don't want them to be able to access any of the data stored with it. So with that sort of planned out, we can write up the policy. We can already see that happening on screen. And while it's being written up, I'd like to bring your attention to the actual nitty-gritty of writing these policies. So policies are written with HashiCorp configuration language, which is a simple data definition language. So we start by defining a path inside of our policy, and then we define capabilities that happen at that path. We've got the star here that can be used to reference all the paths after that point in our Vault environment. So our capabilities roughly align with HTTP actions. So we can read what's at a path, we can create new entries on a path, we can update data at a path, delete data at a path, or list other paths that extend beyond the current path. We've also got a couple of other capabilities within Vault. So sudo, which allows us to have root privilege without needing a root token. And we've got the deny, which explicitly prevents access to that path, which you can see we're using to prevent data in the kv test/data path, explicitly denying that, but we're letting the administrator look at the config and update that as needed. So that's kind of the overall structure of policies. You don't need to write out every single path that gets affected by a policy. Paths are denied by default. So if they're not included, the user doesn't have access to those paths. Right, so now we're just going to quickly scroll through, just make sure everything's all in order, and we can actually create that policy and we can begin to apply that to our user. So policies tie in extremely close with Vault's identity system so that we can ensure policies are applied depending on how a user signs into Vault or what groups they're a member of. For this testing environment, we'll apply our policies manually, but you could also have it set up to apply automatically if a user is a member of a group, for example. And one of the cool things in Vault is that you can sync groups between other identity providers like LDAP or GitHub. So for example, with ACC, a lot of their development stuff is done with GitHub. So if they're using GitHub teams to sort of split up development teams, they can create groups inside of GitHub and have those applied to Vault. All right, so I'm just going to quickly pause this demo here. And now with that in place, now that we've got that policy set up on our admin user, our admin account, we can go ahead and revoke the root token. We don't need that anymore. We don't need to have access to that root token. We can do everything we need to do to configure Vault on a day-to-day basis with our admin account. So we'll quickly do that now. We'll copy the root token here, and then we'll go to the terminal version of Vault very quickly to revoke that token. It's really simple. We're just going to use the Vault token revoke and then paste in that token. And as soon as we do that, we can see that the token's been revoked if it exists. So now we're going to prove that the token's been revoked. We can reload the page here and it will take us back to the login screen, and we can try using that token again just to see if that works. Which it does not. We don't have permission because that token's been revoked. So as soon as we need to get rid of the token, we can revoke it straight away. And then we don't have any more security holes with that token being in existence. So now we'll sign in with our administrator account very quickly. And you can see a couple of small differences with this home screen. We've got a few less options on the sidebar here, and we don't have this information in the bottom right-hand corner. This is because even though we're an administrator, we lock out some of the functionality so that even if this account gets compromised, we've got some level of damage control. Someone with access to this account can't control absolutely everything within Vault. So we now get the chance to test this policy that's been applied to this user and just make sure that it's all working. So we want to make sure that they can configure and view users' policies and secrets engines, but we don't want to be able to have a look at any of the secrets. So have a look now. Just confirm, yep, we can have a look at all of that configuration. Looks good. And now if we try and navigate to a secret within this secrets engine, very quickly try that here. We'll use the experiment secret and we'll have a look at that. And we don't have the permission to view those secrets. We don't have the permission to view the metadata, which is exactly what we want. So our admin doesn't need these secrets. There's no point in them having it. It's just an extra security hole. So we want to adhere to the principle of least privilege where we can. So now with that in mind, we want to test out the ability to make policies. So let's make a new policy for our regular user to be able to access Vault We want this regular user to be able to view all of the secrets inside of our secrets engine, as this might be used for storing API keys and other things that the development team at ACC is using. We also want to have an individual secret set up for each user where they have full control over what goes in there. So the idea is if users are prototyping something for their chat app, they might want others to be able to set it up with any of the secrets that they might need for their local environment, but they don't need to have those changed. It's just the owner that needs to change those secrets. So we'll have a quick look at this policy. We can see with this, the way it's written up, we've got a couple of unique components compared to the admin policy. We've got the wildcard plus, which matches any items at that point in the path. So this will match for data and metadata and technically config as well, but there's no configuration path any further here. We've also got this pattern matching here for the auth/user space with its unique identifier, and this gets the username of the currently logged in user, assuming they've logged in through this user path authentication method. We'll actually show how that gets identified in just a second. And the idea of this is that we're making one policy for all the users. We don't need to specify test user 1, test user 2, and give them all a unique policy. We can just make the one policy that applies to all the users. Something to keep in mind is this is taking the name from the specific user pass authentication method. In a more complex, more finalized Vault instance, we might want to have that set up so that it's actually taking from an entity as opposed to just this specific authentication method. The entity is like a combination of all of one Vault profile sign-in methods as opposed to just the one that's being done with this user pass method. So not super relevant for this demo, but something to keep in mind. The identity system in Vault is really powerful. There's a lot of different options that you can do with that. And with that in mind, you can control exactly what policies users get based on how they sign into Vault. So a lot of different things you can do with that as well. All right, so we've created that policy. We now want to apply that to our user. Exactly the same way as we did with applying the policy to the admin. You can see there we've got the user path identifier sort of mentioned there. So we grab that from the authentication method itself. All right, and now if we go into this, we navigate into the user path authentication method, and we actually start looking at applying this token, this policy to the new user. We'll actually go through, and you'll notice that we apply the policy under the token section. We're not applying it to the user per se, we're applying it to the token. So policies actually exist on the token itself. They're not really associated with the user. You'll see it in just a second. So the idea is that's how we have our root user or root token within Vault. So we don't have a root user per se. We just apply a root policy onto a token, and that's our root token that can do anything within Vault. So now we've sort of adequately tested out the admin policy. We can do everything we need to do for daily administration within Vault. In a real instance, you want to test this for a bit longer, but we'd be safe to deploy this if we wanted to, putting this policy onto our real Vault instance. So ACC doesn't have that set up yet. We're just sort of testing things out, getting an idea of how these policies can be used. But now we also want to test our newly created user policy to make sure that's working the way it's supposed to. So we'll log out and we'll log in. We'll make a note of this username as well, test user, because that's part of the policy. And if we navigate to the secrets engine, we can have a look at some of those secrets. We can see the configuration. There's a few less options there because we don't have control over that side of things. But if we view the experiment secret, we can actually go into this secret here and we can view that. It's not a very secure secret, but just as an example, we can actually see that. We can also see the metadata. It looks a little bit strange in that interface because policy doesn't have the web UI paths. Generally, users aren't going to be using the web UI to access secrets. They're going to be set up through their applications automatically. But now if we look at the test user secret, we actually have a couple more options up the top. We can see version history, And we can see at the top there, we can also delete, destroy, and we can modify this secret if we wanted to as well, because this is matching for that username, like we said in that policy. So this ticks all of our boxes for this user. We can do what we want to with our secret, and we can view all of the other secrets inside of this secrets engine, but we've got what we need to out of this policy. So pretty good test. We could also deploy this policy if we had the full Vault server ready, up and running to go. So, but this is only scratching the surface of what's possible with Vault and policies and identity management. So Vault's policies are one of the most powerful tools this program has to offer. And that's it for this demo, showing actually how these policies can be made, how they actually work, how flexible they are, and how good they are for making sure that there's specific walls around different sections that people need. So after looking at this, ACC is pretty satisfied with Vault. They're looking at what else we can do with Vault if they were setting up their actual production instance, and they're looking at some of the enterprise features. So secrets recovery and performance clustering, which is a big deal for improving the usability of the chat program. You know, if you've got different regions, all need to be able to access the same databases for chats. If you've got that set up with dynamic secrets, like we'll showcase in just a second, then all of those calls to the database will need to go through a Vault instance. If we can have multiple different Vaults around the world that are all the same for performance purposes, then we'll be able to access those secrets really quickly, really easily, and it'll be a good user experience. So that's one thing we'll have a look at, and then we'll also explore Vault Radar, which will assist with moving ACC's secrets into Vault as well. So, but as a bit of a conclusion here, Vault's policies are a massive point of difference between its alternatives. They're a critical factor in controlling access and adding more layers to the defense of this Vault instance. So it's protecting against a lot of the common threats plaguing businesses in this day and age. So it's really important that we get those set up correctly, and hopefully this sort of gives you a bit of an idea of where to start with that. All right, so I'll go out of the demo here. Oop. And we can start talking about those dynamic secrets. So Shiloh, if you want to take over, and we can go from there.
Yes. Can I just share my screen for?
You sure can.
Yep. Yes. Can you see my screen now?
White screen.
Sorry.
Yeah.
Yep. Yeah. Okay. It's my turn. It just covered the vote on the policy side. What I want to pick up from here is a different question. Even after access has been granted, how do we keep the controlling the risk that the credential itself brings? Here is the thing about the modern attacks. A lot of time, attackers don't actually need to hack into anything. They're not breaking encryption. They're not getting past some sophisticated defense. More and more, the attackers just carry out with the legitimate credentials. If you look at where the most breaches start today, they look pretty similar, like GitHub commit, a leaky CI/CD pipeline, a shared token, or the third-party supply chain attack. What attackers are actually hunting for isn't just a vulnerability, it's a long-lived, already existing valid identity. The light LLM supply chain attack back in March is a perfect example of this. Light LLM is an AI middleware library that's sitting between the applications and the providers like OpenAI, AWS, and GCP. We talk about 3.4 million download a day. Basically, every one of them pass through it. But here is the interesting part. Light LM wasn't attacked directly. The attacker first compromised Trivi. Trivi is a popular GitHub action security scanner that Light LLM CI/CD pipeline depend on. Somewhere in that process, LiteLM PyPI published credential got leaked. Then the attacker bypassed the LiteLM CI/CD process, took that stolen credential, and pushed two backdoors versions straight to the PyPI. The malicious code was pretty straightforward. The moment the package got installed, it scanned the local environment for every credential file it could find, packaged them up, and shipped them off to the attacker's server. So a developer runs pipe install LiteLM, goes off for grab some coffee, and by the time they're back, their credential already gone. And that's just the stage one. The stage two, the code moved literally across the Kubernetes cluster. The stage three, it installed backdoor to keep persistent access. 5 hours later, hundreds of thousands of machines had already been hit. At its core, this attack is a code injection, but the reason it could do so much damage is it was harvesting the static credential at scale. We used to ask, how do we store secret safely? But the most important question now is, if a credential might get exposed, can we still keep the risk under control? The answer is one shift from persist access to bounded access. Holding the password no longer means you have access, because the password isn't built to last. The clearest example is how Vault handle database credential. Let's take a look at this diagram. Firstly, we need an admin. Admin does a one-time setup, enable the database secret engine, and tell Vault how to connect with the database and define the role. We will talk about the role later, but for here, it's just the dynamic role, basically what's generated credential should look like and what permission they get and how long they live. After that, when application need to access the database, instead of reading some hard-code password, it asks Vault for a credential. Vault gets the request, creates a brand new user in the database in real time, set a TTL in here is 1 hours, and hands the username and password back to the app. The app uses those temporary credentials to connect with the database. When the time's up, Vault automatically take the credential back. The whole process, no single long-lived credential involved. This sounds pretty good, right? But in the real world, not every application can use this model. A lot of legacy system, third-party commercial software, even some hard-code application require the database username to be fixed and always present. In those cases, if you force a new user to be create dynamic on every request, you might actually cause compatibility and stability problem instead. So Vault also offer another role. It's a static role. With a static role, the database user already existing ahead of time. What multiple clients get is currently password for that same username. It doesn't create user dynamically, so there is no auto-deleting the user when the TTL expires. But doesn't mean the lifecycle control disappeared. Vault still rotates the password automatically based on the rotation period, turning the static password that used to be valid forever into the one that's only valid for a fixed window at most. And this is exactly what mature security architecture should look. It doesn't force reality to bend to the ideal. That means even when you can go fully dynamic, we never give up control the life cycle. But generation alone doesn't make the credential safe. Vault control the lifetime through the four things: list, TTL, renewal, and revocation. In the traditional static credential model, the most dangerous thing a attacker can get is persistent. Dynamic secrets flip this. A credential start counting down the moment it's created. And if something suspicious show up along the way, Vault can revoke it immediately. Maybe in here you will think, oh, these 4 things, seems inconvenience feature, but they are consistently compressed attacker persistence to make sure the credential is finite, controllable, and terminable. And that's only half of lifecycle control. The other half is auditing. Vault logs every action. Because every dynamic credential is unique, the log can tell you precisely which identity and what time got which credential and did what. This is exactly the thing was so painful in the static credential era, because it only show you this shared password get used, but never who actually use it. Here is the one thing the design choice in Vault auditing is worth to highlight. It treats writing the log successfully as a precondition for the operation completing. That means if the auditing log can't be written, whatever the desk is full or network is down, Vault refuse the request outright. It would rather be temporarily unavailable than let the operation happen without leaving a record. And that's why lifecycle control is only truly complete here. It's not just that credential disappeared on their own. It's every step from birth to death. It's impossible to escape the record. And for next step, I will show you a life cycle, how the life cycle look like in both. Here we are. Firstly, we enable the database engine, and the Vault connect to the database, use the root account, and this account usually has a privilege like create a user, grant, and drop user. And for the next step is a security best practice, because I just changed the root database password. That means Vault doesn't just keep the using admin passwords that human knows. It means all credential lifecycle management from that point on has to go through Vault. Like Josh mentioned before, this is defending depth itself. It removes one more long-standing path. And for next step, we're gonna set up a template. And every time application asks Vault for a database credential, Vault follow this template to create a new temporary user. We set up the default TTL is 5 minutes, max is 10 minutes. Okay, now I can ask Vault for a credential. And it creates a temporary database user for me. Here we have a list ID, we have password and username, and I gonna use the password and username to log into the database. Okay, it works. Even though this user was automatically created just a moment ago, it has fully working access to our data. And just imagine now, some suspicious happen, we have to revoke it. So we use the list ID to revoke this credential. Let's try again, use the same password and username. And it's got an error because we revoke it. they will be delayed immediately. And we can check they have 0 rows. That means all the templates, all the temporary vote user has been deleted. And from this moment on, every single API request and response to vote will be recorded. So we're generating another credential here, and this action will be create an audit record. And let me make it readable. So here we are. All the detail in this log, we can see there have a policy, have a name, operation, and time, everything in this log. Yep. So that's lifecycle control in action. Every credential we just saw was from inside Vault, lived inside Vault, and died inside Vault. But what about the credential we never inside Vault to begin with? Vault can't protect what it doesn't know about, right? That's the Vault radar comes in. Radar scan the place secret escape to looking for the one that never made into Vault. Think about a developer hard code API keys into a config file just to test something on Friday afternoon, and the test works, but the key never gets cleaned up. Months later, it's still sitting in the Git hit story. That's exactly the kind of things Radar is built to catch. And for every funding, it does one thing that other scanner don't. Radar a cross check against votes. If these secrets already under vote control, you've got a bad coding habit to fix. If not, you get a leak. When Radar finds something real, it tells you who committed it, where it lives, and how exposed it is. Or it can put the orphan secret straight into Vault to bring it under management. So Vault control what you've got, and Radar found what escaped. Together, that's defending depth for secret, the credential side of it. But here is the thing. What we've covered today is one dimension. In a real Vault architecture, defending deep runs across many dimensions at once. Take a data encryption, that whole separate stack of the layer defenses. Identity is another dimension. Network boundary, another one. So defending in depth isn't a single line, it's a web. And that's a real takeaway. No single layer and no single dimension. It's ever absolute. What protects you is the overlap. When one layer fails and next one already standing, and one dimension is attacked, another one still holding the line. That's all I want to walk through today. Now, Josh is going to show you a demo for Radar. Over to you, Josh. Thank you.
So any questions from the attendees like Tinu and Akhilesh? Anything you would like to add? I know we are at the end of the webinar session, but the Vault Radar demo itself is like 10 minutes. So depending on whether you are available for the next 10 minutes, we can decide whether to do it or we can do it later. So it's up to you.
I have few questions from my side from the previous demo, but those are a bit technical. I'm not sure.
Nalini is from HashiCorp is also available, so please ask.
Okay, but that will snatch away the time for the demo because there are a bunch of them, like at least
Okay.
6. So I think I'm happy for that. Yeah.
Hi, Tinu. This is Nalini. So maybe just make a list of your questions and feel free to email to us. And I think Sheila and Narayan and Josh, myself, between us, we can all help you.
Answer it.
Yeah.
Yeah, that will be better. That will be better. That will save everyone's time. Thank you.
Akhilesh?
I'll do it later on.
Thank you, Tinu. Anything from your side?
No, I'm good. It's a really good demo.
Are you available for another 10-15 minutes?
Yeah, another 10 minutes. Yeah, sure.
Okay, sure. Josh, over to you.
Yep, I'll go as quick as I can then. Just quickly get this back up. All right. So Vault Radar lists primarily inside of Oops Cloud platform. So we'll have a quick look first up at some of the overall features. We can see the main thing is that we're choosing a data source to scan from. So we've got plenty of options. We can do a cloud scan of different cloud platforms like GitHub, GitLab, Bitbucket. There's also a lot of other on-premises or otherwise data sources that are inaccessible to the cloud platform. So you end up being able to scan from AWS, Terraform, CI/CD platforms, Bitbucket, Docker images, and so much more. So you're guaranteed to find where secrets are used inside of your organization using Vault. Vault Radar also has a VS Code extension, which allows developers to instantly see any secrets which might be sitting in the code on their local machines. So developers can find and remediate leaked secrets as they're working, which is one of the main focuses of this demo. We'll actually showcase that in real time as in a demo repository and just see how this actually works. So as we kind of discussed, Vault can remediate secrets automatically, which requires Vault instances to be added under the secrets manager. So the ACC Vault that we've kind of demoed earlier is a testing instance. It's not publicly available, so we're not connecting that directly in here. But if we did have that production instance set up, we could add the secrets found in automated scans directly into Vault. And so for example, after a git commit to a repository, if we're listening to changes in that, we're checking for secrets that might be in those commits and they can immediately get addressed. So the other thing is agents. So this is how we can do on-premises scans as well. So get access to different data from what's accessible from the cloud. And agents can also correlate the data they find with what's in an enterprise vault, and these provide the automated remediation. So being able to combine different types of scans means total coverage of an organization's IT environment to find all of the secrets that they're using. We've also got filters, which can be used to identify different events in vaults and can be set up to notify when risks are found, notify the relevant people, and make sure that they get responded to appropriately. So they require the data sources to be configured and set up correctly. And we've also got global ignore rules, which help to flag specific patterns in code or in cloud storage. For example, if you've got a documentation repository with some sample API keys, they don't need to be included in Vault. They're not a risk. So can flag paths, secret types, and secret values on a global or per repository basis. I've also got some of the remediation options here with some pre-built rules to detect and remediate different secrets. But like with everything that we've shown, there's a lot of customization that's possible. So we can create alerts from here that help with the filtering as well. So and we've also got the actions there which enable specific remediation workflows to exist as well. We've also got the usability tab, which we can use to track where Vault is being used. So we can see how many automated scans are being run and what code bases they're being run on. All right. So now we'll get up the Visual Studio Code extension. Like I said, that's the main focus for this demo. And we can see we've got some sample repository with just some sample secrets. And we'll actually show these getting picked up by the Vault Radar plugin, the extension for Visual Studio Code. So the idea behind this is if you're a developer, you can immediately see where secrets are within your organization or in your code base that you're working on, and make sure that they don't get committed. So it's just on the extension marketplace, and we can see some of the features here. It's enabling that real-time secret detection. It's highlighting where they are inside of the code so you can quickly see where they are, and it gives each risk that it finds a severity. So you'll be able to see that once we actually scan a repository, and we can have a look at that. So in order to make Vault Radar work, we need to have a license key. It's linked to the cloud platform. We'll actually show how to get that license key in just a second. And we can also scan the active workspace or just an active file. So if we've got a big workspace, we can scan everything or just the one. We can also index KV secrets like we showed off in that first demo in a connected Vault server. Again, that requires the connection, which we don't have set up because we're only in that testing environment. So we'll grab the license key here. It's just a matter of copying the license from the cloud platform, and we can jump back to the extension and set that license really easily. It's a really quick process to get this up and running. It doesn't take that much time at all, which is really good. You can immediately start looking for where those secrets are. So we'll set that there. Hit enter, and we can see that it's stored. So we'll reload the window and make sure that gets applied properly. And now we can actually run a scan. We can see what this actually detects, see what it finds within this sample repository. So we'll just open up the command palette within Visual Studio Code. Just a second. And it's as simple as just running the command to scan the active workspace. So that will take a second. We're stuck on that secrets.yaml file because there's probably lots of secrets in that one. And we can see immediately we've got secrets detected. We can see it's flagging exactly what types of secrets we've got. We've got 33 different risks across 8 different files. So we've got what type of secret it is, what type of risk it is, sorry. We've got the severity of it, and we've got a description of it. So, and now we can actually go through these files and we can see exactly where they are. They get flagged in the code so that they can be addressed immediately. We can see we're flagging the IDs. They're not that severe. They're not too bad if we've got the IDs, but we've also got the secrets as well. So that's considerably more of a concern. We want to make sure that we don't actually commit those, especially to like open source repositories. And this sort of shows off the different types of secrets that we can look at. Just as a quick sample, we've got GitHub personal access tokens, same with GitLab. We've got AWS secrets, Azure secrets, and even Vault tokens. So they might be root tokens to Vault. We don't want those getting leaked. We've already sort of talked about the dangers of that. So the fact that they're even showing up in this code base, not great. But we can now respond to those really quickly. We know where those secrets are, and we can respond to those as we need to. We can delete those files, and we can immediately see the difference that those makes, just as an example here. I'll just skip through here very quickly. And we can see we deleted it. We'll run that scan again. And I think it was 33 risks last time. This should drop it down quite a bit because we deleted one of those big files with all those secrets. Yeah, we're down to 19 risks across 7 files. So it doesn't take that long to see quickly how your development changes propagate through to the scan here, and how we can actually respond to those risks before they even get committed, before they even get close to the repository where people can potentially find them publicly. So that's Vault Radar for you. This is a very simple example. There's a lot more stuff that you can do with Vault Radar, particularly if you've got the cloud platform set up. A lot of it requires enterprise Vault to be able to make the most of it, so that you can get that automated remediation. So definitely something to keep in mind if you're thinking of going down the Vault route like ACC has been. This is just another reason on that list that they want to go down the Vault route and that they want to look at enterprise solutions. So But that's it. Any questions in regards to that or anything else? More than happy to answer those.
Thanks, Joshua, for an amazing demo. And I think the demo was so amazing, like it brought up many questions in my mind. So the question list is quite big. So what I feel is personally, I'll try to spend some time and understand it more because this is my first time with HashiCorp application. And overall, definitely I'm getting the context of it, but definitely every product is different the way it is designed. So I'll try to absorb those information with my homework and then come back with filtered set of questions which are arising from this demo. But otherwise, amazing work by the whole team.
Thank you, Tinu. That's great feedback. And, you know, we're more than happy to follow up with some one-on-one discussion with you or anyone else who has any questions about what you saw today.
Definitely, and the demo actually in such a short span of time covered many critical elements of the implementation, trying to demonstrate, I think, end-to-end flow, which was really amazing.
Yes. Yeah, we did cover a lot of ground. And I just want to leave you with this agenda for the forthcoming webinars as well, because in the next demo, we want to have a look at how Vault supports security and compliance use cases. And if there are other topics which you would like us to go into, you know, even something that we covered today, you'd like us to do in more depth, please give us the feedback and we can put that into the schedule too.
Very high level question, which I have right now is like, does this product provide session monitoring also, or is it more focused on service accounts and their credential management?
It's not a PAM product.
Session,
I'll let Nalini answer.
yeah, session monitoring is covered by Boundary. So, you know, the dashboard that Joshua was showing, you know, once you have the SaaS account, it's similar to AWS, right? You create an AWS account and you are able to access multiple services. So similarly, once you have the SaaS account, you can then access Boundary as well as one of the modules. And Boundary focuses on session monitoring and, you know, yeah, more like authentication and every single activity within your session, every single command that you type, that is captured. There is also a video recording, so as an admin, you can then go and play back the video and take a look like what actions a particular user performed. So that requires Boundary. Obviously, it's a HashiCorp product in the same you know, SaaS account, so you can connect or integrate it with Vault.
I got it. I got it now. Makes sense. That's making better sense now. And second high level question I have is like during the demo, I saw the URL for the vault was localhost. That gave me impression like the vault is locally hosted on a system installed by uh, for the demo. So is it so, or does it come as a SaaS variant also?
That's correct. The demo had it locally hosted, but there is an option in the cloud platform. You can have it cloud hosted by HashiCorp as well. So,
Okay. Thank you. That's all for now. I will catch up later on with offline list of questions I have.
Great. Well, thank you all for your time this afternoon, and particularly thank you to Shiloh and Josh for the great demos. And we look forward to the next discussion in the next webinar.
thanks everyone.
Thank you very
Really
much.
appreciate
Thank
your
you.
Thank you,
time.
everyone. Have a
Thank
great
you.
evening.
Thanks, everyone.
Bye.
Bye.
Bye.